The numbers at the top, or from the quotient, are derived from taking the sequential terms of the dividend and dividing them by the first term in the divisor. So for the first one, you have 18x to the fourth divided by 2x, which is going to give you 9x cubed. When you break it down, or rather go from the top to the bottom, just as you did division to go up, you're going to do multiplication to go down. It's just the opposite. So 9x to the third times 2x is going to give you 18x to the fourth, and then since it's two terms in your dividend, rather your divisor, you have to multiply the 9x to the third also by the 1, or whatever term will be over there, which is, of course, the second term. Moving on forward, you take those two things, and now you have a binomial down there below. The binomial is in parentheses. So take that binomial, which is being subtracted, and distribute the negative. So apply it to the 18 as well as apply it to the 9, and repeat this process for the rest of the numbers. The next problem that's going to be demonstrated is x to the fifth power minus 3x squared plus 2x minus 1, all divided by x minus 2. Now that this is taking place, you're going to again get the top numbers, or your quotient, of course, by dividing, and then when you're moving back down to subtract the numbers, you're going to go back down by multiplying. Remember, opposite direction, opposite operation. So x to the fifth divided by x is going to give you x to the fourth power. Then x to the fourth power is going to be distributed to x minus 2. So x to the fourth times x, as well as x to the fourth times a negative 2. Then, just as you had to distribute the x to the fourth, you're also going to distribute the subtraction sign to all the terms that are in your divisor. It only happens now that you have 2, but you can have more than 1 or more than 2 and many, many terms. It just so happens that right now you're doing simple things, which are binomials. The next thing that's going to be demonstrated is synthetic division. Synthetic division can only occur when your divisor is a binomial and has a leading coefficient of 1. Not negative 1, but just regular old 1. Alright, so moving on forward. You're going to take that divisor of 2, which is the opposite, and you're going to compile it or put it together with a dividend that, instead of being 1, then negative 3, then positive 2, includes zeros as placeholders for x to the fourth and x to the third, which are missing. Synthetic division can only be done when your dividend is in descending order. That, in other words, that your exponents have the largest ones on the left, and they sequentially go down, as in consecutively go down, one by one until they get to the last, which would be x to the 0 power, or 1, which is why it's never written, or anything to the 0 power. Otherwise you'd have clutter. So moving on forward, for this you're going to set it up as 1 for x to the fifth, 0 for the missing x to the fourth, 0 for the missing x to the third, negative 3 for your x squared, positive 2 for your x to the first, and negative 1 for your x to the 0 power. Once that is done, you're going to take the 1, bring it down, multiply your divisor by the number that you brought down, and put it up under the second term for your dividend, which in this case is going to be 0. So then, of course, you add those two numbers together. Now, in this case, you're doing addition because, remember, you already switched the signs of the divisor. So that's how you're able to add now, whereas in the other one you were subtracting. But of course, when you switch the sign already, then you can just add, which is how, if you recall back to the long division and just look over there, then you can notice that the subtraction switched to addition for all those examples, which is why now, since you switched the sign, the subtraction is now turned to, again, addition. So let's keep it moving forward. So again, you had the 1 came down, 2 times 1 is 2. Now you have 0 plus 2, which is 2. 2 times 2 is 4. 0 plus 4 is 4. Then you have 2 times 4, which is 8. 8 minus 3 is positive 5. 2 times positive 5 is positive 10. Plus 2, which is 12. 2 times 12 is 24. Minus 1 is 23. We get the exact same answer. That's the way you check it, and that's how you know you did it right. Checking synthetic division is much simpler, but with the substitution method. All you do is use the number you divided by, which again is going to be the root. You're just doing the opposite of what was there. And since you're dealing with a simple binomial of x minus 2 or x plus whatever or x minus whatever, then you're going to be fine. This is, again, what they don't necessarily describe in the textbook. So just substitute the number you divided by. In other words, take the binomial that was your divisor, set it to 0, whatever number you get as your x, which is supposed to be a root, you can now substitute that in, and it should give you the same remainder you got from synthetic and long division. Now, to check this problem, if you were using synthetic division, all you'd have to do is change the positive 1 to a negative 1. But this is a little more complex. So what you have to realize is that divisor on the left is representative of a root. And if you want to use the same method of checking, which is substitution of what you divided by, you're more than welcome to. What's unspoken in the textbook, in the pre-calculus textbook that is that the reason that you use the number divided by is because the number divided by is representative of a root or a 0 or a solution, whatever you want to call it. So take your 2x plus 1, set it to 0. Of course, you'll do the opposite basically of everything that is there. The opposite of positive 1 is negative 1. The opposite of multiplying by 2 is dividing by 2. So you get negative 1/2. Once you substitute negative 1/2 in for all of your x's, then you'll get the same number that you got originally.